Good morning, all of you. Good morning. So, welcome to the course on Foundations of Data Science. This is the first course you are going to learn in your BE Computer Science and Engineering program on data science. Okay, so this will be the first lecture where I'll be giving you a brief introduction about what is data science, how you are to study data science, what are the probable areas which you need to concentrate on your examinations, and so on. As I keep discussing, I want all of you to make notes. So, what are the things that we'll have to understand or study today? So, I've divided this into time. Maybe it does not work out always. There might be changes on the duration at which I'm going to take out each slide. In the first part of this lecture, which is roughly about 100 minutes, next 2 to 3 hours, I'll be giving you an introduction to data science, what is meant by data science Venn diagram, and why there is a sudden boom or sudden need to study data science as a subject. I have completed my BTech from Cochin University of Science and Technology in 2001. When I was doing this BTech course, we did not have a subject called as data science at all. Okay, except for the recent graduates, those who have passed out very recently, we didn't have a subject called as data science. So why today there is a need for a course on data science, and why there is a lot of prominence or importance in studying data science. So this will be the part one of today's lecture. The second part, I'll tell you what is meant by structured and unstructured data. What are the three big V's of big data? Previously, we had something called as big data analysis. There was courses on big data analytics and so on. That was not data science. That's something different from data science. We'll see what is that. Okay. And from there, we have evolved into a new subject, evolution and analytics. What is evolution? What do you understand by the word evolution? We have been evolved from monkeys, right? That means that make changes gradually as time passes. We adapt to new situations. Is that clear? So, what is meant, how we have adapted from big data, data science, and what are the major outcomes of learning data science? What is qualitative and quantitative data? Revision, comparison, probable, academic point of view, all these things are a part of your subject. Okay? So that will be the next part. Data pre-processing and missing values. Yesterday, while giving you an introduction to the syllabus of this course, I told you that we have trillions and trillions of data. We have huge amount of data. We have it organized, unorganized. We have so many ways. We have so much of information that is missing, right? So how we are going to handle these values? How we are going to process the data in such a way that we are going to give some meaning to it. Yesterday, in my discussion, I told you that data science also involves giving some meaning to the data which you have collected, meaning to a raw data. Raw data will be having so many necessary and unnecessary information, right? We are going to convert this into a necessary set of information. That is what is called as data pre-processing, right? And Missing values, of course, you know that when we have, yesterday while discussing, I told you about an example in hospitals where a doctor will be having infinite number of patients and infinite number of information. Some amount of data may be missing, some value may be missing, right? If I ask you to calculate the number of vehicles passing through this highway, you might be able to calculate some values may be missing. For example, if I say that I want the vehicles to be classified as bus, car, truck, or something, right? So each vehicle you are noting it down. You are unable to identify what is the type of vehicle that has passed away. There could be a vehicle which you can neither call it as a truck, you can neither call it as a van or something like that. Or some amount of data, any type of data which is missing. Right? So how we are going to handle this missing data? How are we going to give this values to missing data? So that is all about this. Let me take my pen. That's all about. This is my. This is this. So this is all about this missing values, data pre-processing and missing values. We are making this data meaningful. And then after we make this data meaningful, it is really impossible for us to do everything manually. It is not possible. Okay. I want to get something done out of that information. I wanted to make this data work. I need something called as algorithm. All of you might have understood what algorithm means. You might already have had a basic course in algorithm, so you might have understood what is algorithm. So what is an algorithm? What is machine learning taxonomy? And a very interesting theorem called as no free lunch theorem. Is that okay? Then we'll be discussing some questions and we'll be having some discussion on this. I love interactive classes. I don't want my students to be sitting very quietly and listening to me and me giving you lectures continuously. Instead, I want you to talk to me. I want you to discuss with me in such a way that your knowledge also improves, my knowledge also improves. Every class is a challenge for me. Every student is a challenge for me. Like I told you, I want each and every student in this class to be a professional, to be able to understand, to be able to work, to be able to do research, do so much of wonders in the field whichever I am handling. So you are always free to discuss with me. If you have any problem in understanding my language, you want me to have some translations in between, I'm ready for that. I'm more than happy to do all kinds of services to you. Is that okay? Shall we proceed to the next? So this is just a basic thing. You know that every day, what is quintillion? We are creating around 2.5 quintillion bytes of data every day. Each day, how many people are using Google Mail or how many mails are being sent? Have you ever wondered? Have you ever wondered why memory is a very important storage device? Memory is very important for storing and why it is a very valuable resource. If you have been using your Gmail regularly, you might see that Your data is shown, you are asked to pay money for buying more space. How many of you had this problem before? All of you are using Gmail, right? If you have so many photos, so many videos stored, Google will say your memory is out of range. You need to purchase memory. That means memory is valuable, as valuable or more valuable than money. Memory is very valuable resource. Have you used fitness tracker? How many of you go for jogging or walking in the morning? How many of you go for this? Why? You go that. Good. What about others? See, you can, all of you should keep yourself fit and healthy, do exercises and have good food so that you don't fall sick and you perform much better in your exams. Okay? The idea is that you should be healthy. You are the only person who can take care of yourself. Nobody else is going to give you anything. Maybe they can give you some support, but you are responsible for your health. So you can, I suggest all of you, every one of you, to have good food and good exercise. Every day, walking or jogging is good for your health. So I want all of you to do this. Do do keep doing as small as you can. If it is 10 minutes or 15 minutes or 20 minutes, still it's fine. You can start with 20 minutes a day, just walking around the beautiful campus around you. You learn something, you get fresh air, you breathe something good, and you get some energy for the day. So we have now so many smart devices to track your fitness. Smart watches are there. Okay. It can count your steps, it can count your pulse, it can count so many of things. Imagine the amount of data that it has, right? So a smartwatch is a fitness tracker, so it can generate thousands of data points per second, right? And what happens is that this data that is being generated should be converted into something that can be used every day. So data science is all about creating data and giving a proper meaning to it. Data science na another. What is data science? Please tell me. Giving meaning to it, right? So I'll give you the formal definition for which you can take notes on this. So what is generally data science? Data science is an interdisciplinary field that uses scientific methods, process, algorithms, and systems to extract knowledge and insights from structured and unstructured data. So this part is important. Extract knowledge and insights from structured and unstructured data. So data science means not simply calculating something or giving something. You wanted to give meaning to it. In the example I told you about walking, jogging, and making data points, say for example, you have a sugar patient who is walking, who is a diabetic, maybe your parents, your relatives, or somebody. The meaning means we have to suggest that person how far he has to outperform. What are the things that he has to do more, or what is the thing that he need not do? That's all about that's all about understanding the context of data. So you can expect this question in your exams. Definition for data science. What is meant by data science? So these are some points that you can add on to your notes. Why do people hire data scientists? Why should? These are all important points that is connecting you to your course objective. What is that? What is the need? What is the outcome of the subject? You know that I told you about Gmail. I told you, say for example, I believe that all of you are Instagram users. Am I right? All of you have YouTube. So imagine how many people are there, how many amount of data is there, how many videos, how many reels, how many things are there, right? And if you had read newspapers recently, you might have found that there is a case against Instagram for pornography. You have seen that? How many of you have come to know about this latest event that happened a few days back? The Supreme Court of India had ordered Instagram to censor certain reels, to not to permit certain reels I mean, which is vulgar or obscene. The reels which are created so that women are insulted. All these kind of things, I mean, are being are being ordered by the Supreme Court to censor this Instagram messages. So now we know that in our small class we have everybody using Instagram. So imagine the whole world, how many crores of people are using Instagram, how many people are uploading so many reels, how these things are working out. Okay. So all these examples, whatever I'm talking, these examples, you can write it in your exams also. As an explanation beyond the notes, beyond the regular systematic notes. I want you all to be creative. Creative in the sense that when a question is put to you, you need to think beyond the question. You need to think and study beyond the syllabus. Okay. So now, if I ask you a question, what is the need? Why should you study data science? You can write long, long essays. Am I right? Yes or no? Whatever comes to your mind, whatever you are able to think, you can write in your answers, and I can give you marks on that. I want more creative students. Okay? Creativity na you should be able to develop on the answers. Or if I'm telling you something, you can go much beyond that. You can go much beyond whatever I've been telling you. So I want you all to go much beyond that. I want you all to go much beyond the syllabus, beyond whatever is being done in this class. Okay? We can utilize our data science lab sessions also for this. So see examples are there, Google Translate, Large language models like ChatGPT, all these things are all products of data science. So if somebody asks you, why are you studying data science, or why do you want to study data science in your computer science and engineering course, you need to give a very beautiful and interesting explanation on that. So we must understand what is a raw data. What is a raw material? You have seen cotton, right? You have seen cotton, right? You know what is cotton? All of you. Cotton is being processed and made into shirts, right? With simple cotton as a raw material, you cannot do anything, right? You want a shirt, you need to process this cotton, make it into a shirt, chudidar, or anything like that. Not just cotton, maybe you can use any kind of handlooms. You need to give color to it, you need to do a lot of processing, right? The same way, raw data is something that you get like cotton, whatever is there in your hand. And this data is being processed, pre-processed, and so many other continuous things are being happening. That is called as data processing. Is that clear? From that, we need to understand two important concepts. Basically, what is meant by structured data and what is unstructured data. This is a probable question in your exams. Structured data means, like structured, the data is properly formulated into rows and columns so that the data can be easily accessible. Right? This is structured data. Unstructured data means you have so many information which is not at all properly organized. Coming to semi-structured, we have this data which is not normally visible or normally used. Normally, you cannot understand anything out of it, but you can very easily program that so that it can be used. Some formats like JSON, XML, HTML, and so on. But semi-structured data is not required for you. Your syllabus, we specify only structured and unstructured data. You need to understand and differentiate between what is a structured data and what is unstructured data. You need to differentiate between what is structured data and unstructured data. Okay. Yesterday I've given you some examples, right? About you have rows and columns defined beautifully so that every data can easily be accessed and understood. This type of data is called as structured data. Unstructured data, you have infinite amount of information kept here and there, not properly organized. We'll be using different kinds of algorithms to structure and unstructured data. Shall I proceed? Go to next. So now very simple question, what is a structured data? And the answer for this question is there in your screen. Structured data is data that adheres to a predefined schema or model. It is typically organized into rows and columns where each column has a specific data type. Could be an integer, date, string, or anything of that sort, or can be some objects as we go on. we'll study what is object-oriented concepts. You're already studying object-oriented programming, right? You know what is an object? What is an object? So there is a hint I've given you here for if you are appearing for some exams, national or international competition, you may get some questions, some things like that. If you want to pick up a data within a video, it is an unstructured one, right? You understand? If you want to find out something within a video, what is happening in one particular state or what is being defined at one particular point, that is unstructured. So now we have been looking into the definition of structured data, right? Okay, have you all written down and understood what is structured data? Completed? Shall I proceed to the next slide? Structured data is data that adheres to a predefined schema or model. That means structured data can be directly utilized in algorithms for deducing meanings. Okay, for giving meanings. An example is given here. I told you I'll be giving you case studies. Previously, we had a subject called as Relational Database Management Systems, RDBMS. Now it is only Database Management Systems. But now you see, designing a database is a very difficult task. I'll be giving you projects on that. I'll be giving you case studies on that. Okay. So as such, a video file is generally unstructured. And when you write your answers in your exams, you make sure that you underline the important things because no paper is being completely read and evaluated. Right? Art of passing examination is completely different. You don't need to write stories and paragraphs which is not being read by anybody. You have to write point wise, you have to underline the important points, you have to emphasize certain things, you have to draw maximum diagrams and tables. For example, the question of structured data is being asked, a bigger question, maybe not for 2 marks, for 13 marks or something, any question is asked, you can give an example of structured data. You can give any kind of things like this, whatever I've given. You can give your own names instead of Alice and Bob. You can give your own names. You can give some examples. You can give some tables and so on. That can help you to get more marks in the exams. Okay. These are certain tips that I would like you to follow. So I'm going to the next slide. So what are the three big V's? The three big V's of structured data: volume, velocity, and veracity. These are the three big V's of, and this is a very common question, most probably will come in your exams. What are the three big V's? I told you about big data analysis, right? So recently we have been doing a project on underwater automation, robotics. Okay. Do you know or have you ever imagined the number of species or number of fishes or number of varieties of fishes available under ocean? Not necessarily fishes, could be any kind of animals, right? Have you ever thought, imagined? Don't you think that the volume of the data will be really infinite? Have you ever thought of this? Are you all able to understand what I'm saying? Are you all able to understand what I'm saying? Do you have the habit of watching this National Geographic channel and so on, right? How many of you are interested in that? If you see now, if you go under the sea, you can see that very small area itself, you can say millions and trillions of varieties of animals are available. Marine species are available. Fishes are available. Small, big, different sizes. Tortoises, crocodiles, not crocodiles, maybe something different. So you have, would you think that the information is infinite? So big, volume. If I ask you to calculate the number of vehicles passing, you will have a huge amount of data, right? That's all about this voluminous. When I say volume, it means the amount of data, the bigness. For us, the scientists or computer science engineers, we calculate data in terms of bytes, terabytes, zettabytes, and so on, right? Today we find that in our days, in, as I told you, 1990s or 90s kids, no, what do you call 90s people, no, we had a computer that was made of 1 MB hard disk. 1 MB was so big for us. Today, there is 1 TB, 1 zettabyte. 1 TB itself is how much? 1 GB is how much bytes? 1 MB is how much bytes? Tomorrow I want you to make a small table, okay? Bytes, megabytes, gigabytes, terabytes, and so on. And how many? Tens. Tomorrow I will be asking you this. I want you to show me the table in your notes. I want all of you to keep it written in your notes. These things should be there in your head always. What is GB? What is terabytes? What is zettabytes? And so on. As much as you can. The more you write, the more interesting it is. That is all velocity. That is all about voluminous. Velocity is, of course, the speed at which data is being generated. These are three big V's. I told you why. See, I'm giving you examples in real time so that these things get registered in your mind, in your head. Suppose you're collecting the data of number of vehicles passing through your college in the national highway. Okay. One vehicle goes, after 2 minutes, another vehicle goes. Your data is very easily being captured. But imagine that hundreds of vehicles are traveling at one time very fast. What happens to your system? Okay. The velocity at which, the speed at which the data is generated, then processed. Now I'll give you another one interesting thing. Recently, Anna University Chennai had sent out a project proposal to make drone ambulances. The idea behind the project is very simple. If there is an accident that happens in the road, there should be an automated system which is going to bring a drone ambulance to the accident spot. All of you understood what is the project? All of you understood what is the project? You want me to explain in Tamil also? Not necessary, right? Those sitting in the back, last row, you come forward here. So now, huge amount of data is generated, and this data has to be very quickly processed. Okay, so that's all about the velocity. That means that, can you explain what is the project I told you right now? Anybody there? You can tell in the language whichever you are comfortable. Listen to me. When there is an accident that had occurred in the road, we want a system which is going to automatically detect that an accident has occurred and an ambulance via drone should reach the spot. So imagine that how fast the things should work, how quickly your data has to be processed, how quickly you need to understand that there is a need for an ambulance. You need, suppose if there are two vehicles which are simply dashed, there is no injury or no casualty. Do you need an ambulance? No. So the data has to understand whatever is being captured has to understand that it is an accident that requires a casualty. And all these processing and all these things should be done in milliseconds. Is it not a very interesting project? So you need to understand that the speed at which data is collected and processed is extremely important and is one of the three big P's. Next is veracity. Veracity means the data, how far it is good, how it is authentic, how far it is correct. Okay? If you are giving a wrong data, things will change. As far as we are concerned, as far as machine learning or deep learning engineers are concerned, we are not much worried about the accuracy as such because we wanted it to be 100%. If there is a machine learning algorithm that detects, say for example, cancer, if there are 100 people who have approached this particular system, 95 of them have been detected correctly. The one person who does not have a cancer is being detected as he is having cancer. Imagine the consequence. He's going to take medicines, he's going to be very, he's going to do so many other things. He's going to create a lot of mess, and the machine learning model would fail if it does not detect these things with perfection, or what you call it as precision. What is precision is a technical term. We'll be discussing about precision as we go on in some or the other place. You understood now what is the importance of the accuracy there. If there are 100 people and one person, 99% is correct, detected correctly, but if only one person is there who does not have a cancer, is being detected by your system as having cancer, imagine the consequence of it. What will happen? He will start taking medicines or something, or if at all he relies completely on our system, I'm telling you. So our system should be that perfect. Okay. So veracity means how authentic that information is. In the example I told you about this Anna University project, no accident has occurred, but a message goes to the ambulance saying that an accident has occurred. Imagine so much of energy is being wasted. And this resource may be adversely affecting another original incident that had happened at some other place. So we need to show that the data, whatever is being collected, is authentic. And veracity means how correct the data is. Next is also very much important in academic point of view. What is meant by a quantitative data and what is qualitative data? What is quantitative data and what is qualitative data? What is categorical and what is numerical? So now the real world data is Messi, not the Messi football player. Messi means, yes, Messi means it's totally confused, not properly arranged or properly organized. Okay, so what are the common problems that is being faced from raw data and why do you need to process raw data? The first point is that it has missing values. Sometimes if there is a data that is being, if there is something that is being automated, okay, there might be one common issue that the same data may be repeated at some other place also. So this might be a question, what are the common problems that is being faced while working with real data, real world data? Missing values, duplicate records, outliners. What are outliners? I'll teach you. It's a very important concept. Outliners. What are outliners? I'll teach you. It's a very important concept. Inconsistent formatting. Sometimes you will have values which you don't understand. Okay. These are the common issues that is being faced. This is also a very important question that might probably appear in your exams also. How to treat missing values in a data set? What are the different ways with which we are going to treat missing values in data set. The first one is deletion, very simple, remove the data that is confusing or that is giving you some value that is not consistent with the data. Okay, remove that. The second point is fill it up with mean, median, mode. Okay, so how to calculate mean of a data, how to calculate median, how to calculate mode, I will be teaching you by using Python programs as examples. Okay, two ways of teaching, two ways of understanding. First thing, you will understand what is mode, what is median, if you don't know. Of course, mean everybody knows is the average of few values, right? Average of values is called as mean. Median, mode. I'll teach you what is median and what is mode. I will show it to you with a Python program. Okay? Forward fill. Then we have some machine learning models where we are going to predict what values are the best values in the data set that can be replaced. So I'll teach you how to find out mean, median, mode. All these things are basics of statistics. I'll teach you how to do this with Python program in the next class. So now, whenever you do case studies or whenever you do projects, keep in mind that which method you have used to fill the missing values. Because machine learning models are going to give meaning to the data. It might give a wrong meaning if your missing data are not handled properly. So what is meant by an algorithm? What is algorithm? Definition for algorithm. Algorithm is a step-by-step procedure for a problem to be solved or for solving a problem. So what is algorithm? For example, you want to cook something, right? How many of you are interested in cooking or doing something like that? வீட்டில் எத்தனை பேர் சமையல் பண்ணுவீங்க? Very good. Very good. Suppose you want to make sambar, what you will do? First you need to have that dal or parpu. Then you need to cut the vegetables, right? Then you need to put it in this. You need to keep pressure cooker or pressure cooker illana, you can use some other utensils and so you need to have a step-by-step method of doing it. Now listen to me, all of you, please be silent, especially those in the back. Come and sit forward. Otherwise, I should not hear a single drop of noise. So now, when I asked you how many of you are interested in cooking, I'm sure that most of you will be cooking this sambar. But the taste each one of you makes may be different. You cannot make the same taste sambar as your friend or somebody else makes. You know why? You know why? No, technically, the algorithm with which each one of you makes is different. You know, some people will do something first, the others will do some kind of changes will be there. Some kind of quantity, quality, some changes will be there. So algorithm means a step-by-step way or method in which you are going to solve your problem. First thing is that every algorithm will have a problem statement. Every algorithm will have a problem statement, and you are going to approach this algorithm and solve this algorithm. Solve this problem using an algorithm. Okay? So I believe that everybody in this class understood what is algorithm. Right? Anybody who did not understand, please raise your hands, I'll repeat it. Not only algorithm, you have any queries, you can ask me. Shall we proceed? Oh, next is a very important, very confusing concept. What is meant by supervised learning, what is meant by unsupervised learning, and what is reinforcement learning. These are all machine learning algorithms or different types of machine learning systems, different types of machine learning models. In yesterday's example, now I'll just give you an example and explain to you. You have a patient A who has approached a doctor. Okay, he has inputs X1, and with X1 he has an output Y. Y is the name of a disease. Imagine like this, okay? There is a patient by name A, and this A is having some symptom X1, and this X1 is giving some disease called as Y. Okay? If you know the name of the disease Y and your data set has Ys with the name of the disease known for a particular set of systems, it is called as supervised learning. That means that the data is labeled. Data is having some outcome. Something is known about the data. In unsupervised learning, you have all these things, but the name, the Y is unknown. The name of the disease is unknown in your data set. Okay. The name of the disease is not known in your data set, and your data set has only unlabeled data. In that case, it is a unsupervised learning. Clear? I'll give you an assignment in which I will give you certain examples of supervised and unsupervised examples, and I'll ask you to find out which of these things are supervised learning examples and which of these are unsupervised. I'll give it to you as a Google form, and I'll send the assignment also along with your Google Classrooms. I want each one of you to separately work. See, I don't want you to simply do something. I want you to use your brain and work on that. Okay? Is that clear? Have you understood what is that? Is there anybody who don't understand? This is okay. Now, okay. Now, reinforcement learning is a different type of machine learning where you have an agent and the agent works on the basis of rewards and penalties. Okay, I'll give you a very simple example. You wanted to design a machine learning algorithm for movement of a robot. Okay, there is a robo there and the robo wants to come to me, right? If the robo is coming towards me in the correct direction, you give it a reward. If it is moving in the opposite direction, you put a penalty. In that way, your machine learning algorithm will learn a pattern and will work on the basis of a pattern, right? So if the robo is moving in the opposite direction, it is given a penalty, what it will do? It will come in the other direction, right? So this is a method of reinforcement learning. This is a simple way and a very simplest way of explaining to you what is reinforcement learning, but this is too complex. We'll learn mathematically with equations and so on as we go on. With examples and so on, we'll go on, we'll learn. But now, at present, as an introductory class or as an introduction to this, just for your understanding, I've given you a very simple example. Okay? This is also another very important thing. What is meant by classification and what is regression? Whether it is raining today or not, it's a classification problem because the answer is definite, yes or no. There is only two options. So this is a classification problem. What is the temperature today? Would be a regression problem because you have a continuous value. This is how classification and regression is being differentiated. So we have two important classification problems and regression problems where you have a category or a class or a definite set of numbers. Okay, what we do, we put a range and so on. How to convert these and all these things we will be learning as we go on. Other thing is continuous, where values can keep changing at every moment. What is the temperature? Whether today is cool or not, you can say yes or no. But what is the temperature? You'll have to say 29 degree, 30 degree, 21 degree, or whatever it is. Okay. So when you say yes or no, it is classification. Okay. Or you have not just yes or no, maybe it is a finite number. If I ask you how many students in the class have passed, it's a finite number, pass and fail, whether you have passed or not, yes or no, right? But if I ask the average of your marks or if I ask you some values that has a particular numerical value, it is regression. I hope all of you have understood the importance or the difference between classification and regression. This is extremely important for you. You will be facing a lot of problems which is either classification or regression. Your case study, like say I told you, you're classifying whether an email that is being received in your inbox is a spam or not is a classification problem. Right? There's only two things, whether it is yes or no. So classification and regression is extremely important and you need to understand the difference between a classification problem and regression problem. Okay. So now we have different types of algorithms, say k-means clustering, say, so these are some examples of classification algorithms. What is meant by k-means cluster? How k-means clustering works? I'll teach you. I'll give you a detailed explanation. I'll teach you how it works and so on. But here, what you are doing is that you are bringing all those things with similar features under one category. This is called as k-means clustering. With the graph, you are predicting a new point based upon the distance between the original thing and this one. Okay. So that's the basics of K-means clustering, how it works. The mathematical formulation and other things we'll be dealing with in detail later on. With examples, I'll teach you how this K-means clustering really works. So just make a note of an example of classification algorithm. We call it as K-means clustering. Another example I've given here is about the news grouping. Suppose you have politics, you have sports, you have national, international news, local news, and so on. All these things can be grouped automatically with the help of a AI algorithm or a machine learning algorithm, wherein when you give the content, it is going to classify it into one particular category. That is known as K-means clustering. So next thing is that we need to understand that we'll be using multiple algorithms for every problems. One single algorithm may not give you the correct way of doing one particular things. So we maybe need to use multiple different algorithms, right? See, some of the common examples that we teachers use to explain or make you understand is that you're having a computer shop. You have a customer coming inside a computer shop. How likely is that this person is going to buy a computer from you? This is a problem, right? The output is a classification problem whether he'll buy or not. Second thing is that his social status, his requirement, his need, all these things plays a major role. So all these things will have categorical values. So in order to find out the probability that this person is going to buy a computer or not, you may have variety of reasons. Okay, pricing may be a factor. Sometimes pricing may not be a factor. Okay, so a single algorithm may not work out for many of these major problems. So this is a basic flow diagram of how you give a data scientist a job to understand how a thing really works out. The first part, we understand the basics of the business. Second, data, collecting data, cleaning data, exploratory analysis, feature engineering, modeling. Each of these things I will explain to you in detail when we go on with our course. This is for your basic structure, basic skeleton, just to understand how things are going to work out. And certain things are purely academic, only for your exams. So now this is simply a review of what we have done so far. So data science, we have computing, computer science, maths, and domain experts of the particular verticals. So it is not just numbers, structured, unstructured, quantitative, qualitative, but we are giving meaning to it. So three big data is defined by volume, velocity, and so variety. This is wrong. You can use the word veracity. Okay, VE, veracity. Veracity is better. While I printed, I think it came automatically. So don't write variety, but write veracity. Okay. So how to handle missing data? We have seen the basic method of handling missing data, but I have not taught you how to find out mode and I think mean. All of you know how to find out mean of a value, right? Is the average sum of all the values divided by the number of values. That's mean. Mode and median I'll explain to you with examples and Python program in the coming class. So what is algorithm and so on? I've given you the definition for what is meant by algorithm and I've taught you what is supervised or unsupervised learning. These are the basic things that we have covered in today's lecture. So we have no freelance. What is that no freelance algorithm here? I mean, what is no freelance theorem means that? Do not expect to, we are working on uncertainties. Machine learning, data science, AI algorithms are working on uncertainties. That means we do not know how it is going to give up. What is the way you are going to get the outcome? You cannot predict the way your chat GPT is giving you answers. Sometimes it might be wrong, or sometimes it may be a blunder, or it might be something different that you have never expected out of it. So it means that we are working on uncertainties. Okay, so it is working on some model, some pre-trained models. It's trying to understand something and do by itself. Is that clear? So one type of algorithm, you give like this, you get like this. It's never like that. You need to use multiple theorems, multiple methods, different analogies. Each problem is a very big challenge. So when I give you case studies, what you have to do is that you have to understand that this can be explored in different manner. Okay, explored in different manner. It's very, very interesting and you will see a lot of changes every day. Like the sambar I told you, each one of you makes sambar, there is a different taste. Each algorithm or each method with which you approach a problem is going to be different. That is what is called as free lunch theorem. Free lunch means sambar. Think of that. Okay. Each one of you makes sambar in different ways. Right? Each one of you approach problems in different ways. You need to have multiple ways. We are coming into the conclusion session. So now I'll give you some case studies, I'll give you some examples, and we'll have a group discussion also. You have some ideas related to your learning, I can just give me. See, I'll give you some questions so that you can tell me whether the set of data is structured or unstructured, yes or no. That's also a classification problem. You can classify one set of data as structured or unstructured. I'll give you some data sets and I'll ask you to do some work on that. You need to do those works as we go on. Some case studies will be that we are using mostly case study based methodology. That is why I want all of you to come with your own laptops and work here. with the problems. So these are some of the books which I have referred. The last class I showed you the PDF copies of these books. Okay, some more references I'll show you. If you are interested, you can go and refer these books. Okay, in the coming classes, I'll be showing you Python basics, Panda, NumPy, and so on. Some different uh, packages, how to install and how to work, and so on. So with this, we are concluding today's session, coming to an end. Now it's a question answer time. I told you that I really enjoy interactive classes. I want you people to ask me some questions. I want you to discuss with me something about what we have learned today. You can come up with your questions now. 100 minutes of long lecture almost. If there is nothing else, we can stop. But I don't want things to have be without anything. I want you people to have some discussion with me. Over. Shall I stop?